The Strait of Hormuz is not merely a geographic coordinate. It represents a cold, mathematical measurement of global energy throughput and systemic vulnerability. Every barrel of crude oil that navigates these restricted lanes carries with it the invisible weight of insurance premiums and sovereign geopolitical risk. Roughly 20 million barrels of oil transit this corridor daily, a volume that anchors the energy security of the world's most critical Asian markets. This throughput transforms the strait into a global pricing engine, where even marginal disruptions propagate instantly through freight, futures, and international stock exchanges. In mid-February, Iranian authorities initiated a military exercise that restricted specific sectors, employing a familiar pattern of controlled pressure to signal tactical intent. The operational logic is meticulously calibrated to demonstrate capability while avoiding the self-inflicted economic shock that an absolute closure would inevitably trigger. Closing Hormuz outright would effectively trap Iran within its own export architecture, as its vital oil shipments depend on the same narrow corridor. The true strategic lever is not total blockage, but persistent friction, where uncertainty and delays create costs that often exceed a day of kinetic combat. In the world of high-stakes shipping, risk is translated into currency by underwriters, and that money dictates the behavior of every merchant captain. Hormuz is wide enough for the world's largest supertankers, yet narrow enough that navigation remains entirely dependent on predictable, internationally recognized shipping lanes. When this predictability is intentionally undermined, global throughput begins to plummet long before the first missile is launched or the first ship is sunk. Iran's history of harassment and vessel seizures reinforces a coercive technique designed to operate just below the threshold of a decisive military retaliation. The merchant marine feels these signals first, as commercial traffic cannot simply pause while military units reposition or political leaders negotiate new terms. Constant motion is enforced by the rigid demands of refinery schedules and cargo contracts, making every vessel a potential target in a crowded sea. This relentless motion necessitates constant escort and surveillance, pulling naval resources into a confined theater where reaction windows are measured in mere minutes. Within this tight tactical box, defensive decisions are dictated by geometry, where radar horizons and missile engagement zones are constrained by shallow coastlines. The unfolding episode frames the strait as a chokepoint contest, where the objective is not to win a battle but to create doubt. The next variable enters as U.S. forces respond, moving platforms that compress strike times and expand defensive coverage across the entire maritime theater. A carrier strike group is far more than a mobile runway. It is a self-contained logistics entity that carries its own gravity and industrial demand. Public reporting places the USS Abraham Lincoln at the center of the current presence, with the USS Gerald R. Ford remaining a potent secondary option. The importance of these carriers is purely mathematical, as they generate high-volume sorties without the political complications of host nation basing permissions. However, these massive nuclear-powered decks do not travel alone, relying on an intricate supporting structure of oilers, stores, ships, and escort destroyers. Even a nuclear-powered aircraft carrier requires a constant supply of aviation fuel for its air wing, while its escorting destroyers consume fuel rapidly. These consumption rates force regular replenishment cycles at sea, a process that is not a convenience but a mandatory tempo governor for operations. Every refueling evolution exposes the ships and constrains their maneuverability, anchoring the entire strike group to a predictable and vulnerable logistics schedule. Military sealift command vessels act as the quiet enablers of this power, carrying the fuel, ordnance, and parts that keep crews functioning indefinitely. Deterrence is ultimately built upon the strength of these supply chains, yet supply chains create patterns that an adversary can observe and stress. The narrative now shifts to what is notably absent from the current buildup, specifically, the lack of large-scale troop transport or reserve activations. This absence suggests a strike-centric posture rather than a ground-heavy campaign, though it does not mitigate the risk of a sustained aerial confrontation. The strait's mounting pressure collides with regional constraints, as local bases and overflight routes are political assets that can vanish without warning. When land-based access becomes uncertain, the operational burden shifts towards standoff weapons and maritime basing, which trade inventory for geographic distance. In this framework, every day of heightened tension consumes more than just fuel. It burns through airframe life and finite missile stockpiles. Escalation often begins as movement, which signals readiness to the adversary while preserving the strategic decision space for political leadership. In a constrained sea, even undefined objectives carry immense danger, as the mere density of sensors and patrols increases the probability of collision. Iran's asymmetric playbook is optimized for these conditions, utilizing drones, mines, and shore-based missiles to exploit the narrow, crowded shipping lanes. These tools are effective because they leverage the physics of the environment, short flight times, and minimal maneuver room for high-value targets. A single, successful strike is not a failure of courage, but a statistical reality of mass launches and the requirement for perfect defense. This creates a one-sided quality control problem where the defender must be successful every time, while the attacker only needs a single breach. Deterrence is therefore an engineering contest, designed to convince the opponent that the probability of any meaningful success is approaching absolute zero. But these probabilities are shaped by time and repetition drives the mechanical wear that eventually degrades every military platform involved. The Strait becomes the opening act because it forces the immediate allocation of scarce resources under the intense glare of public scrutiny. It also forces a brutal trade-off. Either protect commercial shipping from friction or concentrate forces for a decisive strike against shore targets. While Iranian messaging is presented as calibrated flexing, the physical outcomes, higher insurance premiums, and tighter convoys are tangible and immediate. Carriers and their escorts represent the visible layer of power, while intelligence and cyber preparations remain the invisible, unspecified foundation of the campaign. In this strategic structure, the Strait acts as the throat and logistics as the bloodstream, where the next act follows the oxygen supply. Once aircraft begin flowing in large numbers, geography stops being a static map and transforms into a rigid, time-sensitive operational timetable. Distance in this theater is paid for in refueling brackets, maintenance hours, and the constant management of finite crew endurance. The audience is left with a simple constraint: narrow seas compress decision time while global energy dependence magnifies the cost of miscalculation. Every additional ship and aircraft deployed reduces strategic ambiguity but simultaneously increases tactical exposure within the opponent's engagement range. The build-up's primary logic is throughput management, keeping the oil moving while positioning the heavy steel necessary to strike if the order arrives. The second act of the campaign begins not with the launch of missiles, but with the silent, essential movement of millions of gallons of fuel. Range is the primary adversary that every air campaign must defeat long before it encounters the kinetic resistance of an integrated enemy air defense. When aircraft deploy across oceans, they move through a complex ladder of tankers, diplomatic clearances, and preposition maintenance nodes scattered throughout the theater. Public flight tracking and Pentagon releases have recently confirmed the rotation of F-15E Strike Eagles and F-16 Block 50/52 aircraft into the region. Each platform carries a specific burden of logistics and mission requirements that define the opening sequence of the campaign more than any political headline. The F-16 Block 50/52 fleet is specifically tasked with the Wild Weasel mission, a role dedicated to the high-stakes suppression of enemy air defenses. Suppression is not merely a prelude to combat, it is an absolute condition for the survival of every strike package entering contested Iranian airspace. Integrated air defense systems must be systematically blinded, distracted, or destroyed before any sustained aerial operation can achieve its primary military objectives. Iran's air defense network combines aging Soviet-era systems with newer indigenous components and advanced S-300 variants that extend their engagement range significantly. An integrated system remains dangerous because its inherent redundancy creates overlapping fields of fire that can absorb and recover from localized damage. The Wild Weasel calculus is unforgiving, as emitters that radiate can be targeted, while those that remain silent force pilots into dangerous, high-speed guesswork. This lethal cat-and-mouse dynamic consumes sorties rapidly, as suppression is a continuous pressure that must be applied throughout every hour of the fight. Each seeded sortie requires multiple tanker brackets, and these refueling windows define the actual size of the combat operation more than airframe numbers. The U.S. Air Force's KC-135 and KC-46 fleets are finite resources, and readiness challenges within the tanker enterprise constrain the tempo of modern war. Tankers are high-demand, low-density assets whose inherent vulnerability dictates exactly where and how fifth-generation fighters can operate in a contested environment. If regional overflight permissions are restricted, refueling tracks must stretch outward, increasing fuel burn and reducing the critical time on station for strike aircraft. Time on station is the campaign's most valuable currency, as defensive counter-air and suppression missions compete for every minute of fuel in the sky. The presence of F-22 Raptors signals a clear intent to control the air domain rather than merely contest it through localized air-to-air engagements. Air dominance is achieved through sensor fusion and the ability to survive inside advanced missile envelopes that would be lethal to legacy fourth-generation aircraft. Yet even the most advanced fifth-generation aircraft require constant maintenance cycles and secure land-based facilities to generate their repetitive, high-volume combat sorties. High-tempo operations accelerate the consumption of spare parts and shorten the inspection intervals required to keep these complex machines flight-worthy and lethal. Logistics at this scale becomes a matter of industrial plumbing, requiring massive fuel farms and ground crews working in exhausting, around-the-clock shifts. Previous operations have demonstrated that the flow of fuel itself often becomes the ultimate constraint, necessitating rapid infrastructure upgrades to sustain surge demand. Fuel is a physical vulnerability, delivered via pipelines and trucks that remain exposed to both political interference and direct physical disruption by the adversary. If host nations restrict combat sorties from their soil, aircraft remain present but limited, forcing the campaign's geometry to shift toward the sea. In such scenarios, carrier strike groups absorb the operational load, which in turn increases the pressure on maritime replenishment and aviation fuel cycles. The suppression of enemy air defenses must synchronize perfectly with maritime posture, ensuring that land-based and sea-based aviation share the same tactical windows. The first wave of strikes must degrade command nodes enough to permit follow-on operations without prematurely expending the theater's scarce and expensive munitions. High-speed anti-radiation missiles like the AGM-88 HARM are effective tools, yet their production rates are measured in months rather than days of combat. A stark economic asymmetry emerges when an inexpensive, mass-produced drone can provoke the launch of a sophisticated interceptor costing millions of dollars. The U.C. response now includes laser-guided rockets adapted for counter-unmanned aircraft missions, offering a significantly more economical engagement option for the defender. Recent defense contracts have accelerated the integration of these cost-effective systems across F-15E and F-16 platforms to counter the growing drone threat. Counter-UAS operations are no longer peripheral to the mission. They are central to the defense of high-value assets against Iranian saturation tactics. Saturation tactics compress the decision time of commanders, forcing them to prioritize targets when radar screens are simultaneously flooded with incoming threats. The mathematics are blunt. If dozens of objects approach from varied azimuths, even the most sophisticated layered defenses can be pushed to their limits. Patriot batteries and regional missile defense assets extend the protective envelope, but they also operate within the strict limits of reload and coverage. Public CENTCOM statements consistently emphasize that layered defense is the governing principle for protecting regional bases and critical maritime infrastructure from attack. This layering reduces the overall risk, but does not erase it, as each layer introduces its own coordination demands and potential technical seams. The opening hours of any air campaign hinge on precise sequencing, where suppression flights clear corridors for strikes under a protective air shield. Sequencing requires a coherent air tasking order that integrates Navy and Air Force sorties into a single, unified, and high-tempo operational cycle. The Combined Air Operations Center acts as the metronome for the entire theater, assigning targets, refueling windows, and critical deconfliction blocks to pilots. If the strategic objective extends beyond a single night of strikes, the operational tempo must be sustainable rather than merely performative or theatrical. A sustained tempo eventually reveals human and mechanical fatigue as crews rotate through high-stress missions with increasingly limited periods of recovery. Extended deployments strain the retention of skilled personnel and overall force readiness, a theme echoed in recent congressional reports on military management. Air power is a vast industrial conveyor belt, and like any machine, it will fail if the bearings are allowed to overheat under constant load. Every additional squadron deployed to the theater increases the potential for strikes but also multiplies the demand for maintenance and spare parts. Iranian leadership must weigh whether their air defenses can impose a high enough cost to fracture this conveyor belt before their objectives are met. The United States must calculate whether its tanker demand and munitions expenditure remain within the sustainable margins of its current industrial base. This represents the second strategic cliff. If air logistics falter, deterrence weakens because a visible presence without repeatable strikes invites a challenge. When the integration of suppression and tanker support holds, the campaign can escalate with controlled pacing toward its broader and more decisive objectives. The third act shifts offshore, where aircraft carriers function not as mere symbols of sovereign power, but as floating industrial airbases bound by rigid maintenance cycles. Public reporting confirms that the USS Abraham Lincoln has maintained a presence in the region, while the USS Gerald R. Ford serves as a potent secondary option. A carrier strike group is a complex, interdependent ecosystem composed of the carrier itself, guided missile destroyers, logistics vessels, and a highly specialized air wing. Each element within this naval formation is designed to solve a distinct operational constraint: strike generation, advanced missile defense, or critical maritime replenishment. The Lincoln is among a select group of U.S. carriers specifically configured to sustain F-35C operations requiring unique structural cooling and jet blast deflector modifications. These modifications are necessitated by the F-35C's extreme engine heat and onboard systems, making the requirement for specific decks a physical rather than bureaucratic limitation. This technical constraint narrows the pool of available decks capable of sustaining high-volume, fifth-generation sorties across an extended combat theater. In contrast, Ford-class carriers introduce electromagnetic launch systems and advanced arresting gear, promising significantly higher sortie rates once these technologies fully mature. However, this maturation carries inherent risk, as reliability challenges in early Ford-class service have been documented in recent government accountability assessments. Technical reliability is paramount because sortie generation is a literal measurement of aircraft cycles per day, sustained over weeks of potential conflict. Public Navy data has historically cited surge capacities exceeding 150 sorties per day under optimal conditions, though sustained combat typically produces lower averages. The Air Wing's diversity, comprising strike fighters, electronic attack platforms, and airborne early warning aircraft, defines the carrier's multi-domain flexibility. Electronic attack platforms like the EA-1AG Growler are essential for degrading enemy radar, working in tandem with land-based suppression assets to clear the skies. Carrier-based aviation reduces the reliance on fluctuating host nation permissions, yet it deepens the dependence on the relentless cadence of maritime replenishment. Even a nuclear-powered supercarrier is tethered to fleet oilers, such as the Kaiser-class vessels, which must deliver massive quantities of aviation fuel. Replenishment at sea is a highly disciplined choreography that requires ships to operate in close proximity, temporarily concentrating risk and limiting maneuverability. During these replenishment windows, the strike group is at its most vulnerable, anchored to a predictable schedule that an adversary can monitor and exploit. The guided missile destroyers in the escort screen carry vertical launch systems stocked with a mix of Tomahawk cruise missiles and defensive interceptors. Public specifications list dozens of missile cells per destroyer, creating a massive aggregate strike inventory when multiple ships operate as a unified force. The presence of an Ohio-class guided missile submarine, such as the USS Georgia, adds significant covert Tomahawk capacity to the theater's strike options. These submerged platforms complicate an adversary's defensive calculus, as their precise launch positions remain uncertain until the moment of impact. This layered strike inventory, spanning surface ships, submarines, and air wings, is deep but ultimately finite, with reload operations tied to specific port access. The maritime picture also incorporates expeditionary support bases and auxiliary vessels that enable special operations and maintain persistent maritime security. The sheer density of U.S. naval presence in this theater compounds global strain, as ships are cycled between Indo-Pacific and Middle Eastern commitments. Congressional testimony frequently highlights that the total fleet size remains below long-term force structure targets, increasing the burden on every active hull. Fewer available ships mean that every deployment extension reverberates through the entire maintenance schedule of the United States Navy. A carrier delayed from its planned maintenance cycle creates a maintenance debt that compresses future shipyard availability and inflates long-term costs. This debt accumulates invisibly until readiness metrics begin to decline, often only surfacing during high-intensity inspection and certification cycles. Public reporting has acknowledged significant backlog pressures at public shipyards, where industrial capacity is finite and modernization timelines frequently slip. When a carrier remains on station beyond its window, other vessels waiting for critical repairs must adjust their schedules, driving up systemic instability. Within the confined waters of the Persian Gulf, geography compounds these risks because reaction times for missile defense are shortened to mere minutes. The Fifth Fleet's area of responsibility includes shallow, restricted waters where maneuvering space for massive supercarriers and their escorts is dangerously narrow. Proximity to shore-based Iranian missile systems creates a persistent vulnerability, as short-range ballistic and cruise missiles reduce the warning window significantly. A successful strike does not need to sink a carrier to achieve a strategic victory. Any damage that halts flight operations shifts the global narrative. Missile defense at sea relies on the Aegis Combat System and SM-series interceptors, coordinated by sensor data from airborne early warning assets. This layered defense integrates shipboard radars with the E-2D Advanced Hawkeye to extend the detection range beyond the ship's physical horizon. Yet the problem of saturation persists, as the carrier's magazine depth must compete with the volume of an adversary's mass missile launches. Every interceptor fired reduces the available defense against subsequent waves, creating a mathematical limit on how long a ship can withstand pressure. This economic and tactical asymmetry surfaces again as low-cost offensive systems attempt to exhaust the fleet's high-cost defensive interceptors. Navy doctrine emphasizes maneuver and distributed operations to complicate targeting, but these tactics simultaneously increase fuel consumption and coordination complexity. Coordination in a contested environment requires secure communications, which are constantly challenged by the adversary's electronic and cyber warfare capabilities. The final act of this strategic contest turns from posture to probability, where escalation is governed by inventory depth and political thresholds. Cyber operations add an invisible, lethal layer to the conflict, capable of disrupting port logistics or fuel distribution without a kinetic explosion. Defense analyses warn that cyber-induced delays in the supply chain can produce cascading operational failures that ripple back into sortie generation. The campaign's overall sustainability rests on synchronized resilience across all domains, not on the success of any single, dramatic kinetic strike. Industrial capacity in the United States remains the ultimate limiting factor, determining how quickly advanced munitions and ships can be replenished. Deterrence is reframed not as a single event of willpower, but as an endurance contest between two industrial and political systems. The Strait of Hormuz remains open, not because it is invulnerable, but because the cost of its closure is enforced daily by visible, layered presence. Fragility lies in sustained strain. The longer the standoff continues, the more the industrial and human bearings of the system begin to overheat. The story ends with the acknowledgement that endurance, calculated in fuel, missiles, and maintenance hours, will ultimately determine the outcome of the crisis.